Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of vectors. What is a vector? A vector is anything that has direction and has magnitude or length. How do we get a vector from 2 points? Well, you might have remembered vectors as rays or directed line segments from geometry in high school, where you might be learning about it right now. But basically what you do is you take the terminal point and minus the initial point, or subtract the initial point from the terminal point. Okay. The vector can be either written with angled brackets like this, indicating the I, then the comma J, then comma the K position, or X, Y, Z directions, or it can also be indicated by these I, J, Ks, which indicate for X, Y, Z. So given 2 points, how do we determine the vector? Well, just do each component minus each other. So you do the X minus the X. Let's see if we can get a different color. And then for the Y minus the Y. And then the Z minus the Z. So here's a vector, 2, 2, 0. And basically that tells you to move in the 2 in the X direction, 2 in the Y direction, and because it's 0 in the Z direction, it's on the XY axis. If you wanted to draw it three-dimensionally, it would look something like this. You would need an axis first. So let's see, let's pick a color for the axis. Let's go with blue. So what I'm going to do is I'm going to draw the XY axis first. And then I'm going to draw a line 45 degrees going through it. And this is going to be your positive Z-axis, or the K direction. This is going to be your positive X-axis, or the I direction. Forgot to put little hats on them. And this is going to be the positive Y-axis, or the positive J direction. Okay? So if I was going 2, 2, 0, what I do is I go 2 in the X, and I make my hash marks parallel to the axis that I'm coming out of. So in this case, parallel to the y-axis. And then 2 in the x, or in the y direction, so parallel to the x-axis, 1, 2, and then these guys intersect somewhere over here. Okay? So the vector would be flat on the xy axis. Let's say it had been 2 to negative 3 or something like that. So we would have gone 2, 2, but on the negative 3 level, if that makes any sense. So what would have changed? Well, let's see. We still would have gone 2, 2, but then we would have gone down negative 3 units. So it would have been something like this if we did 2, 2, negative 3. Just to give you something that's just not on the XY plane, something that's got a little bit more depth to it. So hopefully you can visualize this and practice on your own. All right? So back to vectors. So what is magnitude? Well, the magnitude is basically finding the distance, and you take each component, square them individually, add them together, and then square root them. That's how you find the magnitude. So of our vector 2, 2, 0 we just found, if we take 2 squared, 2 squared, 0 squared, add them together and simplify, there's our magnitude right here. Let's go back to yellow. Okay. All right, let's go down a little bit. what's a unit vector? Well, if you remember, I told you vectors have two things. They have direction and magnitude. When you take away the magnitude and give it a distance of 1, it then becomes a unit vector. U. Okay? So v vector v over the vector quantity over a scalar quantity. A scalar just means it's a single number. It's not commas or ijk's. It's not a vector. So we have 2, 2, 0, and the magnitude for that was this. So if you just take, calculated above, so if you just take that 220 divided by 2 root 2, each component, you get this here, and then your final answer for your unit vector would be 1. Or, I'm sorry, for your unit vector would be this, and its distance is 1. All right, well, how else can we get unit vectors? Make sure that if you're given an angle, you use this formula, cosine theta. This is only for 2 dimensions, sine theta. So if you were given 35 degrees, the components are as follows. How does that come about? Well, let's look. Each vector you have can be broken down into components. There's going to be an x component and a y component. How do you get each one? Well, these are the formulas for them, but it's easier to understand where they came from instead of just memorizing formulas. So if you look at the sine of this angle, because this is a right triangle, sine is the opposite over the hypotenuse. If you solve for v sub y, that's how I got that. It's pretty straightforward. Then same thing with cosine of theta is the adjacent over the hypotenuse, which is v sub x over v. And then when you multiply both sides by v, you get the x component. All right? So if you're asked to find components given angles, don't freak out. Just plug into the formula or derive the formula, whichever you feel more comfortable doing. So for the x component, you can see you just take the radius in this case and multiply it times your cosine of that angle, which is root 3 over 2, and then sine of the angle for the y component, and then put it in vector form. I, comma, j could have also been written for that example. Okay? So here's the three-dimensional coordinate system. What you need to realize now is that we've gone from 4 quadrants to 4 on top and 4 on bottom. So that's octants now. And this is just showing you the different axes. I've already showed you how to do this, but here's plotting 3, 1, negative 1, 1, this point here on a three-dimensional axis. Okay? So you would go 3 in the x direction, then you would go back 1 unit in the y direction, and then up 1 unit to the z direction, and then you draw a line going from the origin to that point if it's a vector. Okay, but if it's just a point, you just draw a dot there. So there's the point drawn as a vector. All right? Okay, so then after that, we're going to go through some applications of magnitudes and things like that. This handout can be found on dallaseducation.org. We're going to go through some applications, and we'll also do some dot product and cross product multiplication. So make sure you check out part 2 of the concept video of vectors, operations with vectors. All right? Hope I've cleared up any confusion. Practice, practice, practice as always. Thank you and have a nice day.